Well, it's an interesting, question of have the problems, some people articulate the viewpoint that organic chemistry, synthetic organic chemistry is a very mature field. No, it is an old field. It's something that's been developed for 100 years. But I would argue it's still fantastically immature, because if you think of the classes of molecules that we can prepare in a routine way, there are very few. I mean, we can now prepare nucleic acids, peptides. Those stand out. There's a lot of development recently in carbohydrates and polysaccharides. But when you get to any type of functional array that hasn't been subject to absolutely intense work for over decades, I think you find that it's not routine. And if that's the case, I think the field cannot be considered mature. And I think that's also true. An example I give, a related example, is in terms of predicting reactivity. Some of them ask, what reactions are really reliable? And I say, well, lithium aluminum hydride reduction. I can reduce most anything with LIH, but there are not many reactions. When you encounter those, I think they're very special. I think, in fact, we've invented one that is of that type, the Isocol-Monish reaction, a very reliable, robust reaction. But there aren't many. And I mean, there are many. I'm not just obviously saying that's a unique one at all, but there are not 50 or 100. We have thousands and thousands of reactions, and their scope and reliability, the robustness, has very often not been defined yet. Until that's done, I think you would have to say our field is very immature. I mean, it's, to me, like, would a computer scientist be content if when he writes code, it fails 99 times and then finally it works when he gets that solvent, the equivalent of having the solvent change that makes it work? I would say no. They'd say there's still very much, it's very immature. It's in a development stage, and I think that's still very much where we are.